Good afternoon to you all out there. Welcome to this SAW webinar on welding careers. My name is Shelton Zichao, and I'm going to basically take you through this short discussion on welding. And this here, as you can see, is our head office, which is located in City West here in Johannesburg. And then just a quick, a few facts about SAW. We were established in 1948. We've been around for about 72 years now. And we were one of the founding members of the International Institute of Welding. We've got two other branches. We've got two branches, one in Cape Town and one in Durban. And we also have a footprint across the African continent. So you know, where you find SAW is known not just in South Africa. Okay, so welding. To start with, welding is basically, you know, a process where we are joining materials together, and depending on the situation or circumstances, it can be the same material, it can be different materials. So just to get us started, I've you know, got a few illustrations of areas where welding is widely used. So here I've got a petrochemical plant. We've got a few of these in South Africa, Sasol Secunda being one of them. And within this sort of environment, you find that there's chemical processes that actually need to take place in order for these organizations to produce whatever it is that they aim at manufacturing. A number of products are produced in petrochemical plants. So different processes actually take place. Some of them require high temperatures, others require a low temperature. For those particular reactions to occur. As such, you find that the materials that are needed then have to be, you know, appropriate for those particular operating conditions. And then further to it, the chemicals themselves also have got an effect on the material, because the chemical processes take place within pieces of equipment. So all these are things that have to be taken into account. When you start to weld, or when you're planning on welding any piece of equipment, you have to be aware of where you're going to make use of it. And then going further, we also have got, the power generation industry in South Africa that is typically like Eskom. So there you find that generally they heat up water, or they boil water in simple terms and convert it to high pressure steam, which is then used to drive turbines, which in the process generate electricity for us. And, as I've said, there's heating that takes place, which means to say that this is a high temperature environment. There's lots of tubes that are used here, which are mostly joined together using welding. And again, the materials have to be appropriate for high temperature use, okay? Also, there's degradation that does take place once you start running these pieces of equipment. And then if you think back in terms of the power plant and the petrochemical plants that I was showing you, all those are basically made up of various pieces of equipment which are, built as a single unit and then connected together to have the entire plant, as I was illustrating to you earlier on there. So there's a lot of welding that takes place in workshops, manufacturing companies, and then they ship out those pieces of equipment to the different locations for use. And then if we zoom in a bit more into the petrochemical plant, you can see that there is an illustration of a smaller piece of equipment that is connected to other pieces of equipment. And if I'm to zoom, give you a what can I call it, an X-ray view of this particular unit here, this is what it would basically look like. As you can see, there's actually tubes inside. It's called a heat exchanger. And you'll find that with some of these pieces of equipment that are manufactured using welding, there's other bits of equipment which will also be inside, the big unit itself. So it means to say that when you manufacture those various pieces of equipment, you need to know exactly what you are doing. You need to apply the relevant standards. You have to have an understanding of the materials. You have to know exactly what needs to be checked, to ensure that you've manufactured everything correctly. And then taking the application fields of application further, you find that welding is also used, in the transportation industry to manufacture the different, modes of transport that we use. So I've got here an illustration of the shipping industry, but you also do use, welding in such other areas as the rail industry. Transnet is a case in point. In the motor industry as well, all those different cars that you drive, there's some welding that actually takes place there as well. This thing move. My slide doesn't want to move forward. I don't know. Just give me a minute to try and get this thing going forward. Okay. Wow. I'll skip. All right, there we go. So besides the transport, sector, also when you look at buildings, the structures in the structural industry, welding is also used to manufacture some of these structures. And when we think of structures, quite often, you'll be thinking of a simple shade on a farm, or but structures can be very, very complex, and there is a lot of danger in a structure not being made to the relevant standards, such that if something were to go wrong and that building were to come down to the ground, a lot of people would be hurt and killed as well in the process. So welding becomes very, very critical. It has to be highly regulated to ensure that the products that are being manufactured are being done so at the relevant standard, or to meet the right quality levels. Okay. And then another example of a structure is it's a bridge that we've got here, made out of steel. And then again, we also use welding in the manufacture of pipelines. And the great thing about this image that I've got for you right now is that it actually shows you it actually brings to light another phenomenon related to welding, which is that we don't always weld inside a workshop. At times you can weld out there in the bush, like this example here, with the pipeline. The guys are welding out on site, okay? So that basically is some examples of where welding can actually be used, or areas where you can find yourself working if you are involved in welding. And then in the field of welding, there are a number of options in terms of careers that people can actually pursue. So before we delve more into the different options, I just want to have a quick discussion here. I talked about the petrochemical plant, where we were talking of the different temperatures, pressures, the chemical constituents that have to react within those pieces of equipment. So for all of that, it means to say you need to have engineers or designers, the guys who, the ladies and gentlemen who will actually, put a concept onto paper, and then that concept, or the drawings, the design, is then handed down to a group of guys that would call the coordinators. So it is the job of the coordinators to then, allocate this work to the different people within the workshop. And so in this example, in this cycle that I've got here, I've got welders. So it is then the job of the welders to follow the instructions that they've been given by their coordinators or the supervisors, and they must do as they've been instructed to do so. And again, the coordinator is also supposed to then check and see that the people that he or she has allocated work to are actually doing what they are supposed to, in terms of the instructions that they were given. And then further to that, we also have another group of people, which is called the welding inspectors. The welder has to, as with any instruction, you have to do what is on that particular instruction. You should not go and then do your own sort of thing and, change things here and there. But we all know that we are different in terms of how we work and think. So, which is why you tend to have supervisors in the very first place. And then we then have the welding inspectors. So the job of the welding inspector is to see to it that what the engineers wanted has been fulfilled. So the coordinators and supervisors will largely be responsible for bringing into reality what the engineers wanted, but the inspector is there to verify that indeed this thing has been manufactured in accordance with the relevant standards, in accordance with the necessary stipulations or requirements which were basically laid down. Okay, so that this is basically the cycle, or a simplified cycle of welding, and it basically gives us the framework upon which I'll be talking about the various careers that can basically be pursued in welding itself. Okay, so moving forward, I'll start off with the welding inspectors. In terms of the welding inspectors, we at SAIW, we offer the welding level 1 and level 2 welding and fabrication inspectors. So these guys, their responsibility, as I've just been explaining a little while ago, is to see to it that they double check and that everything has been done correctly. They are more or less like a third party, that independent body that comes to say you have indeed complied with the requirements. And if things are falling short, they will also help you to in identifying where you've fallen short and what corrections need to be made there. Okay, and we also have got an IIW qualification, which is the comprehensive level. And it's also, again, a field of, it's also within the field of welding inspection. And we also have got paint inspectors. They are, with all those pieces of equipment which were manufactured, you find that, as you saw with some of the images, I think they're painted. So the quality of painting has to be right for the purpose of preserving those pieces of equipment from deterioration. The environments bring about things like corrosion. So you want to see to it that your pieces of equipment do not degrade, much faster. They tend to have a lifespan that has been designed into them or built into them. So you want to guarantee that lifespan by, putting up protective measures such as paint. And then I've got here another area in welding, which I've just put under welding inspection, but otherwise I should have maybe had it on its own. It is the post-hole heat treatment practitioner. Now, the post-hole heat treatment practitioner is slightly different from inspection or the coordinator. Their job really is to see to it that after the product has been manufactured, or there tend to be a need to give these materials a post-hole heat treatment, which is basically heating them up to relieve stresses, to just change the metallurgical structure a bit. So it is their job to do so, these practitioners. It is an area of speciality on its own within welding as well. Okay. So here's an illustration of a product that has been manufactured using welding. And when we look at this particular product, we've got an inspector in there analyzing, assessing this particular product. This here is a boiler, and a few things that I can basically mention to you here. You want to check and see that the welds, are they of the right size, as an example. You want to check and see that the dimensions, are they correct? Has this thing been manufactured in such a manner that it meets the sizes as were required by the design engineers. So there'll be drawings that you basically go and check all of these against. You know, you want to check and see that the materials that were used here, were they the correct materials? Though you don't check for some of these things right at the end. I mean, it's a process. You start with it, you know, before the manufacturing actually takes place. That's where you go and check and verify. Again, you want to see to it that the welders themselves, are they competent for the work that they are doing? So you want to see that they are qualified. And that qualification comes with its own restrictions. So it's, you know, being a qualified welder does not mean that you can go and weld up anything. There is limitations to it. So the limitation can basically be the thickness that you can weld. The limitation can also be in terms of the material that you can weld, or the particular process itself that you can weld using. So those are all areas that the welding inspector goes to check and see to it that you know, everything's been done correctly. And looking again at this particular image, you'll see here, if I can move my cursor here, towards the bottom of the picture, there are these white, these white marks that you see here. This is another area of inspection, which Mark Digby is going to discuss with you tomorrow. It's called non-destructive testing. It is also the job of the welding inspector to see to it that all these other testing methods have also been applied. The primary purpose really being that verifying that this product meets the necessary quality requirements. And then, so if we look at areas where, or the organizations that employ welding inspectors, I've broken them up into 3 bits here, which are, just want to try to, okay. So these bits, basically, I've got the client inspector, I've got the manufacturer's inspector, and I've got the third party. So I'll give a simple scenario of how these all come together. So at times you can just have the client and manufacturer's inspectors only, and at times you can have all 3 working together. So what can happen at times is that if I take like the client here, for example, like a Sasol, they can want a particular piece of equipment to be manufactured for them. So obviously that will be the manufacturer's job to do so. And the manufacturer will have his team to manufacture this, you know, fabricate this particular piece of equipment. But the manufacturer will also have an inspector working for him to see to it that his team or her team have actually manufactured this thing correctly. And again, the client will have an inspector who will also be going to verify that the manufacturer is indeed producing this you know, piece of equipment to their satisfaction, to the requirements of whatever applicable standards might be you know, required there. And then you also do get what we call third-party inspectors, or AIAs. These guys are actually independent of the client and the manufacturer. So the client can actually call the third-party inspectors in to go and double-check what the manufacturer is doing as well. So they are basically an independent, they're like a referee in a football match, you know. It is their job to say, you've done the job properly, here you've made some mistakes, you need to correct here and there, that sort of thing. So the typical organizations for third-party inspectors would be such as TUV, Bureau Veritas, OSG, okay. And then moving on, going back to my circle, we've got practical welding. So you can't weld anything without the guys that actually do the physical welding itself, okay? So these are just some of the methods that are used in welding. These are the most dominant welding methods that you'll find out there. The very first one being shielded metal arc welding, very, very common. I think most of you would have seen this used in all sorts of places in your neighborhoods at times, you know, guys just doing small repair work. And then you've got other processes like gas metal arc welding, which use a continuous wire. It's a semi-automated process. Basically, the wire is fed by the welding machine, and it is the job of the welder to locate the arc in the groove in the right place within the groove itself, and to traverse across the groove or along the groove at the right speed in order to ensure that they are depositing a weld of good quality, consistent thickness, consistent depth or height and width. Okay, and then you also have got other processes like gas tungsten arc welding. This process, we typically want to use it for producing high quality welds. And a typical example of that, as you can see here, with small diameter piping and small thicknesses. And again, it is ideal for depositing what we call the root run, which is basically the first layer of weld that we deposit when we are joining two materials together. It tends to be of a superior quality, the weld that is produced using this particular process. And then once we've laid down our root, we can always fill up that groove using any of these other processes that we've got here. And then I've got on the bottom right side of your screen, we've got this process called submerged arc welding. With this particular process, it's a mechanized process. It's a slightly different form of welding. It uses very high currents. The wire that is typically used here is much thicker than what these other guys in the image here in front of you typically use. So this process is basically used for doing very thick welds where you want to deposit a lot of filler wire in a short space of time. A human being would not naturally be able to handle the sort of speeds, the sort of current, the burn-off rate of the wire. A welder won't be able to quite handle all of that. So the whole process becomes mechanized, which basically means to say that it is operated by a machine. The people that operate this process are called welding operators. Their responsibility is to simply, set the machine. What current do I need? My wire feed speed, the voltage, and then basically see to it that this piece of equipment traverses along the weld, and to ensure that the weld is being deposited in the right place. Okay. And then there's with welding. So with the other processes that I was showing you, we can always you can always pursue another career which is a bit more niche, if I may put it that way, where you become an international welder. This has basically got 3 levels to it. The first of them being a fillet welder. So you basically specialize in depositing fillet welds. You can use any of the manual processes that I just showed you from the earlier slide. And then you can further progress your abilities in terms of your skills to becoming a plate welder. And once you satisfy the necessary requirements there, if you wish, you can take it further to becoming a pipe welder, and you get a qualification from the IIW for all these 3. So you can be an international fillet welder, an international plate welder, an international pipe welder as well. And these are IIW qualifications, but we are not only limited. You are not only limited to getting an IIW qualification. You can also just be trained upon a particular need, a welding need, to fulfill a particular mandate within your organization as well. So it can be tailor-made to suit your needs. And then we also have what we call the international welding practitioner. This is one level up from the international welder. It's more a supervisory role or a coordinator type function, but a practitioner needs to be a qualified welder. They need to be able to weld. You can't be a practitioner if you cannot weld. It's very, very important that I emphasize the need to be able to weld. Okay, and there's some theoretical knowledge which you can acquire, so it gives you a good understanding of what is taking place. So you're combining your practical knowledge as well as your theoretical knowledge to be able to make good decisions in terms of what needs to take place within the shop floor. Okay, so that's the practitioner. And then further with welding, you also have got a bit more of a sophisticated area, which is the robotic welding. With robotic welding here, the robots are the ones that actually do the welding itself. You can see there's a vehicle there that is being welded. So the job of the operator here is to simply program the robot, give it the instructions, tell it where to move to go and, you know, place the weld itself. So do you want the weld, if I may speak very simple, generic sort of terms, do you want to weld the boot? Do you want to weld the front door? You know, where exactly do you want to weld? Or is it somewhere on the sunroof? You know, just as an illustration. So you actually have to give the robot the instruction to be able to go and weld at those particular locations. Okay, and then further to that, you then have to put in the welding parameters. What current should it be welding at? What voltage should it be welding at? You know, those sort of parameters. So that's another area that can be pursued in terms of welding careers as well. Okay, so moving on from welding careers onto something different, we're going to talk about welding coordination. With coordination, I've got here the 3 areas. It's not just limited to these 3 areas. So the practitioner I've mentioned a little while ago, and then we also have what is known as a welding specialist. The welding specialist receives more theoretical training and does not necessarily need to be a practical welder, but that in itself does not mean to say a welder cannot become an international welding specialist. So with the welding specialists, they receive a whole lot more theoretical knowledge to be able to guide, so that they've got the adequate knowledge to make the necessary decisions on the shop floor in terms of the work that they are handling, in terms of addressing the welding challenges that they may face. So it is actually a good tool for anyone that wants to supervise, you know, work on the shop floor to resolve welding problems. This is a good area to actually pursue. And then we also have got the international welding technologists, and these guys receive even a much more superior level of theoretical training regarding welding technologies. So they get to have a much broader understanding compared to the specialist and the practitioner, you know, in terms of the different welding processes, the challenges that you encounter using different processes, and how you can basically go about resolving those challenges. You know, the different materials, each of those materials tends to come with its own sort of problems. I think when I mentioned with the petrochemical plant, we talked about, you know, the high temperature service, low temperature service. Those materials are not the same, you know, that are used to manufacture those pieces of equipment that must work in those sort of environments. And the times you combine different materials to each other, you know, you weld different materials to one another, and that in itself poses different challenges. There's all sorts of things that can potentially go wrong. So when you pursue this line of work, it is your responsibility to see to it that those things do not, you know, those things that can go wrong do not become a reality. Rather, you plan and you manage all the welding well to see to it that you produce exceptionally good quality products. So that is it from a welding coordinator perspective. And then there is another area which I've not put up here, which is the international welding engineer. I suppose some of you might have heard of that. You would get training on that at the universities, Pretoria, University of Pretoria, University of Witwatersrand. You can go and receive training there if you want to be a welding engineer. But you need to be an engineer for those. With the international welding technologist, you know, if you came through, say, to SAIW, you can actually pursue this line of, you know, this training, and the requirements are not the same as for university. So it actually opens up the area for a much broader audience of people that want to pursue careers in welding. All these courses that I've got here, or these career paths that I've got here for you, they've got different entry requirements. So basically you have to look at your own circumstances as an individual to sort of say, can you be a welding practitioner? Is it a specialist that you are, you know, qualified to become or a technologist. If not, you can start at whatever level you are able to enter the field of welding, and you progress upwards. That's the great thing about all of this. So a practitioner can, with time, progress to becoming a welding specialist, and a welding specialist can also, with time, progress to becoming a welding technologist as well. So that is one of the great things with a career in welding. You're not just limited to whatever level you started off at. There's still room for growth there. And with these courses which you've been seeing, which we've been saying international, like international welder, practitioner, specialist, technologist, these are courses which SAIW basically runs under the auspices of the IIW, which is the International Institute of Welding. So it means to say that the certificate that you get is actually from the IIW. And to give you a picture of who makes up the IIW, it's basically all these countries that you see here are highlighted in red. I know there's COVID right now, COVID-19, which is terrorizing us, and the map is kind of looking like this, but trust me, this is actually the IIW map. It's not the COVID map at all. Okay, so it's actually quite spread out all over the world. So it means that with your IIW qualification, potentially it can be it's recognized in all of these parts of the world. Okay, and then when these pieces of equipment have been manufactured and they've been put into service, one thing is definite, which is that they are going to deteriorate. There is corrosion that is going to take place. They will not always remain in that brand new state that we had them when we manufactured. So we have to check every now and again to see to it that these pieces of equipment are still able to keep functioning. So you find that there's something called a minimum thickness, as an example. This is important because the piece of equipment was designed to withstand particular pressures, a particular temperature. So if it goes below that thickness, what then happens is that it is no longer structurally sound to withstand the operating conditions, meaning to say that it becomes a risk. For example, it can actually explode. Okay, and then it becomes an accident which potentially damages the plant. It can potentially hurt people, the environment, and also other. It can potentially kill people as well. So it becomes important that whatever goes into service, it also needs to be checked while in service. And in South Africa, you find that there is a law which actually regulates all of this. It requires that every 36 months, pieces of equipment which operate under pressure need to be stopped, opened up, and you let a group of people go in there to inspect these pieces of equipment and check and see to it that they are still well capable of operating in a functional, in a sound and safe manner going forward. Okay, so this group of people, they are called competent persons. There's basically two groups that I can talk to you about. So you've got what we call competent person pressure vessels and the competent person steam generators. These are different pieces of equipment which operate under pressure. So they are very high risk pieces of equipment which we do not want to have any incidents going wrong there. So here, it's another niche area within welding, but it's more or less, I can basically simply describe it as being a post-welding career, meaning to say that the pieces of equipment have been put into service, they've been operating, and therefore your job is to go and check that these pieces of equipment are still, are still in a good condition to satisfy the operational requirements. Okay, so that is another area of a career in welding. And then that basically brings me to the end of my presentation. So in a nutshell, we get the guys that design the welds. We get the guys that, the coordinators that basically allocate the work and manage the problems that you have out there on the shop floor. And then you also get the welders themselves. You get the welders whose job it is to combine or join these materials together. You get the inspectors. With the inspectors, I can basically split them up into two. The first group being those guys that check the pieces of equipment as they are being manufactured on the shop floor. Okay, so they are basically looking at what we can call new builds. And then you also get the guys who examine these pieces of equipment or inspect these pieces of equipment when they are now in service, which is this last group of guys that I've got here for you, which is called the competent persons. And then the other beauty with the career in welding is that you can actually, pursue any of these. Besides pursuing any of these, you can actually pursue one or two of them, so you can choose to specialize in the one area, or you can combine all of them. There's no restriction, there's nothing that says if you're a competent person, you need only be a competent person. If you want to be, an inspector of new equipment, you are welcome to do so. Okay, so that basically brings me to the end of my presentation. Okay, my slides don't want to move, kind of stuck. There we go. All right, so I don't know if there's any questions. I don't know if you're popping any questions into our chat forum. If there's any questions, we will gladly answer them, or you can basically send them in the form of an email to us, to my name there, shelton.zichawa@saiw.co.za, or to lizberry@saiw.co.za. Okay, that basically is it from me. I think I'll just wait for your questions, and I'm just going to put up one last slide, considering that we are in COVID-19 times. It's important that you guys remain safe at all times. Okay, so if there's any questions, please go for it.
Shelton, question from Mark.
Yeah.
Which welding method is the strongest?
I see. Which welding method is the strongest? Well, Mark, the answer to that question, really, it's more about the filler wire that you actually use to combine these two materials together. It's not so much a question of saying which welding process is the strongest. You rather choose the material, the wire. So the wire has to match the base material that you're going to be joining to it. So you can't, if you choose the wrong wire, or a wire with a weaker strength than the base material, then it doesn't matter which process you basically used, that joint will actually fail. Okay. Any other question?
Did you see?
I see there's Petrus. He'd asked a question which says, which welding process would be the most in demand for future uses? Well, Petrus, it's a bit of a difficult question to say, but looking at it, it really depends, I would say, on the level of automation that is going to take place. It really depends. So, for example, if you are going to work in a highly automated environment, then a process like robotic welding would be the most appropriate. But you find that processes like SMAW are still very, very popular, and I think they'll still remain popular still going forward as well, because of the flexibility or the portability aspects that it brings with it. So yeah, there's not one that I'll necessarily say that this is the most appropriate for the future. There's other welding processes as well. I didn't mention that earlier on. There's numerous processes out there, more than 30 welding processes. I can think of things like friction stir welding as an example. So it really just depends on the particular sector that this is going to be working in. And then I think you, Petros, you had also asked me a question on the future of welding as a sector. Yeah, that is actually quite an interesting one. But the reality of it is that if anything is to be manufactured, most of the time there's welding that is involved there. And so right now in South Africa, there's not much work that is necessarily taking place, but that does not mean to say that you cannot look outside. There is still, projects that are taking place anywhere else. Companies are actually sourcing work from outside of South Africa. There's a lot of work that's taking place in Africa, as an example. So there's quite a bit of scope in terms of welding out there. And then Dimitra is asking me a question. I see there's a question here. All right, I'll answer the question from Jerome Jacobs. Jerome asks, he's a welding assessor and wants to further his career in welding, and wants to know which courses can you suggest on your side to further my career in training young welders. Jerome, my answer to you would be start off with the International Welding Practitioner, IWP course. That would be the ideal starting point for you in terms of, upskilling other people. That is actually the course that we recommend for anyone that is to work as under what we call an authorized training body for a welding school. Okay. And then Dimitra had asked the question on how long it will take to become a welder. That there is no one answer, one size fits all approach to it. It really depends on your welding skills. And so one person can actually, and again, the level to which you want to acquire that skill, what sort of skill are you looking at? For example, is it just going to be welding in the flat position, or do you want to be able to weld what we call in the 6G position? So that takes up a different time frame. Do you need a matric to study welding? No, you can start off as a practical welder. You don't necessarily need a matric for that. Okay. Okay, I've got a question here from Lerato. It says, I have a diploma and MTech in metallurgy. So Lerato, if you want to actually become a qualified welder, so my understanding of a qualified welder to start with before answering your question is a person that actually welds, does the physical welding itself. So if you want to do that, you'll be starting from scratch. There is no, at what level? So you'd have to start right from the basics, to learn how to be a welder there. Okay. Yeah. Let me see what other question I've got here. Mark says is welding for everyone. Well, Mark, we've got different career paths within welding. So as I've just been explaining, you choose which path basically suits you, whether you want to be a welding inspector, whether you want to be, a welding coordinator. It really is, you can choose which one best suits you there. All right, I take it there are no more questions. Right, if there's any other questions, guys, feel free to drop us an email and we will gladly get back to you.